Solid buildings. Matyas Gutai, University of Tokyo.
Hello, hello everyone. Thank you very much for the possibility of today. It's a real honor. My name is Matyas, and as you can see, I'm an architect, and I build buildings by water. I know using water as a building material, looking at drops as bricks, sounds pretty crazy, but please don't worry about that, because for an architect, that's actually a really nice compliment. Breaking the wall of solid architecture is a very important story, because architecture has been exclusively defined by this one element for 12,000 years. And actually, if you look into it, you will realize that a lot of problems of our current architecture is actually not the problem of architecture, it's the problem of solid architecture. Transportation, energy consumption, carbon dioxide emission, and a lot of problems regarding to sustainability actually all are connected to solid material use. That's actually because our building environment, when it comes to thermal behavior or when it comes to structural behavior, it's pretty much dead, just like a moon. It's unity of mass and insulation and tries to achieve stability in such manner. Because architecture is all about stability. Unchanged state of structure and unchanged state of microclimate and environment. To achieve that, architecture, because of solids, is based on the misconception that strong is stable, unchanging in time. In reality, architecture should be much more like planet Earth, in which case any effect, structural or thermal load, is immediately counteracted with an immediate effect, a response of the structure. That's exactly what water structure is all about. And the water house we build can do that with embedded responsiveness based on the material properties and not because of external monitoring or external control or environment. A structure like that works very much like the bones, which deconstructs or reconstructs based on the immediate effects of the strain itself and not because of the brain control. And that brings you towards an architectural system that works very much like stems in plants, where water is actually a column and also a structural element and environment. And that solves you a lot of problems, embodied energy of structural materials, recycling, because we are talking about a dual loop here, in which materials of nature and industry are only lent and united temporarily for the sake of architecture and released back to where they belong. And it builds, where is my next slide? I don't know. And it builds an architectural system that we constructed, which case the behavior of the system is constantly changing on immediate environments and effects, and that results a patented technology. Thank you very much.
Thank you. How you deal with the phase change in water, ice, vapor, etc.?
Yes, basically the main key is that we are achieving stability and unchanged state. So if you come to think of it, the water in the end, if the system works, and it actually works, it's a long to explain, I will later, then the temperature does not change at all, so it does not freeze. And we also challenge it with biological solvents in the water itself.
Cool, thanks.